This is our video for Tuesday, April 14th for pre-cal. Our objective today is to use determinants in a couple of applications. So just kind of a reminder, on Monday we learned how to find the determinant using a calculator. Today we're going to look at two uses of determinants. Tomorrow we are going to talk about how to use determinants in the process of using Cramer's rule. Thursday, we're going to talk about inverses, matrices, and cryptograms, and then we will have our quiz on Friday. Remember that all of these assignments are due by Thursday midnight, and then we will have our quiz on Friday. All right, so yesterday we talked about how to find the determinant with a calculator. So today we're going to look at page 536, and that's applications of matrices and determinants. And today we're going to talk about two different uses that are very similar to one another, but we can use determinants, believe it or not, to determine the area of a triangle. We can actually use determinants to figure out the area of a triangle. So if you're going to use this formula, so first of all, the area of the triangle, you have to know the points of the vertices. So normally, to find the area of a triangle, we think of 1/2 base times height. And you would have to know some distances. But to use determinants, you just need the vertices. So if you could remember this formula, and they give you 3 vertices and ask you for the area of a triangle, you could find it rather quickly with your calculator. So the formula says that the area is going to be equal to plus or minus 1/2 the determinant of x sub 1, y sub 1, and the number 1. X sub 2, y sub 2, and the number 1. X sub 3, y sub 3, and the number 1. And so if you take the coordinates of your 3 points, and each set of ordered pairs gets to have its own row with 1 as the third number in the matrix, because it has to be a square matrix. And if you take the determinant of this matrix, and it doesn't matter which point is in which location, you just need to make sure that you have your ordered pairs together in the same row with the number 1 at the back. Put this in to your calculator and find the determinant of it, and then take half of that, and area is always positive. So the plus or minus is there to make sure that the area is always positive. So let's look at example 1 there on page 536. It says find the area of the triangle whose vertices are 1, 0, 2, 2, and 4, 3. So we want the area. So we're going to use this formula right here. So the area is going to be plus or minus 1/2. And I'm just going to take the points. So I've got 1, 0, 1, 2, 2, 1, 4, 3, 1. And I need to put that into my calculator, just like we talked about yesterday. I'm going to go second matrix. I'm going to go over and I want to edit matrix A. It's still a 3 by 3, but it's 1, 0, 1, 2, 2, 1, 4, 3, 1. So I've got my matrix. And I'm going to take the determinant. This time I've still got it in there from the other day. So I'm just going to hit second enter, and it's going to repeat. And it says that the determinant of this is -3. And the formula says I need plus or minus 1/2 in front of that. And so this is supposed to be the area of the triangle formed by 1, 0, 2, 2, and 4, 3. And so we can't have a negative area. So I'm going to use -1/2 times -3 and my area would come out to be positive 3 over 2. And so if I were to graph the triangle with vertices 1, 0, 2, 2, 4, 3, that triangle would have an area of 3 over 2 square units. So pretty simple, pretty quick way to find the area. And the calculator makes it much nicer. All right, so that is our first application of determinants. Our second application is very similar, and you can use determinants to determine if 3 points are collinear. Now, if we were together in our room, I would ask you, what does collinear mean? And I hope that you would say that collinear means they're points on the same line. Same, linear is line. So they're points on the same line. So we're trying to figure out if we have 3 points that are on the same line. Well, if we have 3 points on the same line, those 3 points will not form a triangle. So collinear points cannot make a triangle. So to determine if 3 points are collinear, you are going to see if the area of a triangle formula is equal to 0. And if it's equal to 0, then the points are collinear. That means that a triangle was not formed. But if the area of a triangle is equal to a number, if there is area there, then the points would not be collinear. So if we look at example 2 on page 537, it says determine whether the points -2, -2, 1, 1, and 7, 5 lie on the same line. Are they collinear? So we're going to set up the matrix like we did for the area. And so we're going to take each point. So -2, -2, 1, 1, 1, 1, 7, 5, 1. And we want to see what the determinant is. And so I'm going to get my calculator. I'm going to go back and change. This is still a 3 by 3, but it's -2, -2, 1, 1, 1, 1, 7, 7, 5, 1. All right, and I'm just going to hit second enter, and this determinant is equal to -6. So that means that these 3 points would form a triangle that would have an area. If I were trying to find the area, I would take -1/2 times -6, and I would get 3. So these 3 points would form a triangle that has an area of 3. But that wasn't the question. The question was, are these points on the same line? Are they collinear? And the answer would have to be no, because they form a triangle that has an area of 3. So if the determinant is equal to anything other than 0, the points could not be collinear. So if you were to go to page 544 and look at number 9, it asks if it says use a determinant to determine whether the points are collinear. You've got 3, -1, 0, -3, and 12, 5. And so you could pause the video and plug those in and see what your determinant is. Now, when you type that in and find the determinant, it ends up being 0. That means that these 3 points are collinear. So again, the question was, are these collinear? And the answer would be yes. They do not have an area between them, so they do not form a triangle. So For your work today, you are going to be determining whether 3 points are collinear, and you're also going to be determining what the area is between the triangle formed by the 3 points. You're basically using the same determinant setup. It's just if you're doing area, you'd have the plus or minus 1/2 in front. If you're doing collinear, make sure you answer yes or no. So on page 544 for today, I want you to do number 2, number 4, number 6, number 10, and number 12. So 544, 2, 4, 6, 10, and 12.